Hey, my name is Eric. I am an Angular developer. I started about 7 years ago with Angular 1. I've been doing it professionally in my job for the last 5 or 6 years, starting with Angular 1 all the way up through through today, Angular 11 we're on nowadays. Um, and this video is a continuation of the previous one where we were working on a um, little test helper to stub out and mm, uh, um, test and control asynchronous methods in a similar pattern to the way Angular's HTTP controller works, HTTP testing controller, I should say. So that's this guy. So in the end, we want to have an API to work with in your tests that are is going to be very similar to this. And so, we can find matching function calls rather than HTTP calls. They're going to be method calls. Find matching method calls, expect them, expect one not to be there, verify that none are left that you haven't already expected. And this is not a tiny endeavor. We're already on video 2. I imagine it's going to take even more than this. And here's my little GitHub issue I made for myself, starting to sketch out what the API may look like. And here is the code from last time. So, this video is just going to continue along, basically. So far, we wrote this match method, which is pretty much doing what it should, I think. So what's left, I suppose, is to go make this test call actually work, this test call object. That's what we get inside these matches. We're going to want to add the test call. We're going to want to add a flush and an error on those guys. So that's going to be similar. I should pull this up for reference as well. Let's look up what's it called, and the Angular HTTP is called test request. So test request. So we're going to want an API similar to this. Canceled, we don't really have that, but the call we already have, we're going to still need flush and error, and there is no event. So that kind of sounds like maybe as good a place as any to continue from. And so let's do it. Let's do it. So I'm going to continue with the TDD style of development like last time. So we're going to write a failing test, then we're going to write the code to make it pass. I pulled my sleeves up at the beginning of the last video once I got to the actual coding as well. Something subconscious. So when I write my tests, I always like to write them at the level, and I like to interact with my code at the same level that the user will. So when it's an actual Angular application test, I'm going to be simulating mouse clicks or what the user actually does. When I'm doing a library like this of test helper, I'm not going to create one of these test call objects myself. I'm not going to test it in that small isolation like maybe you've heard recommended before. I find that less convincing and of a test. I want to use it the same exact way a user will, and show that all the code between the user and whatever I'm testing is all working together correctly. So I really tend to lean toward integration tests mostly, and do, unless I have a real real algorithm like I have a Sudoku app, and I don't think it has any tests yet, but if I write tests for the actual like solving of the Sudoku, maybe then I'll actually write unit tests, but otherwise it's all point and click style tests, or in this case, I'm not going to create a test call object. I'm going to basically interact with it the same way I was the async method controller, because this is what we're going to use that returns these test call objects. And that's how a user is going to get at them. So let's just copy a test and use that as our starting point. And let's see, let's do flush first. Oops. Oh my gosh. Okay, here we go. Huh. Wow. All right. So what does flush need to do? Let's have it. It causes the call to resolve with the given value. So the API I want here, once I get a hold of my test. So let's do a read text call. We're going to sort of the sort of test case we're using for our the scenario we're using for our test cases for these helpers is the Navigator clipboard. Navigator is provided by the browser. It has this clipboard object that you can use to read and write from into the real system clipboard, so copy paste. And so we create a new controller for this read text method. That has the old name. In the previous video, I was struggling to come up with the right name. I think I'm happy so far still with method controller. So let's call this, instead of a stub, let's just call it controller, and let's update that in our other tests while we're at it. In fact, let's just, any place we have that, let's now change it to controller. All right, cool. Let's save that, and I'll just run the test real quickly to make sure I didn't break anything with the simple rename, because I didn't use a browser refactoring. I just did actual like text find it all replace. But we're good. Now read text. We need to be able to see when this resolves and that what value it resolves with. So the test call is going to be, if we just match on true, that should give us our test call. So this, we made one call to it, and so the controller has stored up in its memory one call to this function that we basically stubbed out that we're controlling in our test. And match is the only function we have so far to interact with it, so that's the one we'll use, and we'll say give us all of your matches, and then we'll index out the first one. That's the only one that's actually there. Now we should have a test call object, and so we're testing .flush. So if we do now test call .flush, which doesn't exist yet, we're going to need to expect something. Okay, we're going to flush it with the clipboard text, and then we're going to expect we're going to expect something to equal the clipboard text. Now, how do we want this API to work inside here? How do we get a hold of the test call and see what, or sorry, how do we get a hold of, how do we set this up so that we can test that this value is actually flushed out correctly? Which then is to say, as a user of this API, if what I'm trying to test is actually the clipboard, how do I, some code I wrote that uses the clipboard, how do I want to be able to interact with that? Let's say, I think let's make a spy, and let's just set that as a dot then spy. So now we're going to be able to tell when the API, the Navigator clipboard API resolves, which is what we're trying to control with this flush. Then it's going to call this spy, pass it the value that was flushed, and that should be good to go. So we're going to, let's see. Before the test, we're going to expect the spy not to have been called. Then afterwards, we're going to expect a single call, and I'll explain this function in a second, to the spy with the parameter with this same value. Now, let me explain this. I'm going to delete this one, but let me explain what I've done so far. Expect single call and reset is a helper that I already have in, actually it's in ngdev, come to think of it. So I probably should import it straight from ngdev. So this repo has many libraries in it. It's a mono repo that I publish as separate npm packages. Excuse the car alarm outside my window, if you can hear that. Oh, there we go. So these are arranged by their dependencies. I talked about this in the last video. The result was we are writing our code in this particular library called slibs/ngdev. And so I want to import this not from the packaged up slibs, but from, let's see, maybe I can get new options here. Import it from, import it from this relative directory. Okay, so this is a helper which, here I'll just pull it up and show you the docs, which expects exactly one call to have made to a Jasmine spy and for it to have received the given arguments. Then it resets the spy. We don't care about the reset for our use case because this is the last call, the last expression in our test. But the reason it resets it is, later if we keep using that spy, we can test each time and it will have reset it. So when you say expect a single call, now after this, it will, after this, that would pass. It thinks that's been reset, that it has no method calls anymore, and we can reuse it again. So anyway, long explanation to say we're not using the and reset part of this, but it's still handy because otherwise we would have to say that, these two lines, I suppose, ourselves, and we wouldn't care about the third, but now it's all nice and succinct in that one line. Okay, as I said in the last video, I like to set these up when I can as a real simple, like, set up the code, exercise the code, so in this case it's the dot flush, and then expect it with a blank line in between each one. So initialization, exercise, expect. So that's certainly a failing test. It doesn't even compile yet. So first let's make it compile, which I can use my editor to help me with. This is good to get used to. It fills in lots of helpful typing information for you and things like that. If you write the code as if it exists first, and then I'm using WebStorm. I'm not sure. Last I knew, and it's been a while, last I knew VS Code did not have this feature, but maybe it's been built into like the TypeScript language service since then or something like that. Anyway, use your editor features. If you're doing this full time, if this is your job, spend the time, learn your editor features, and benefit from it. Okay, so here we have a test that should fail because this does nothing. It's not going to cause the spy to be called with any value at all. So let's get that test call spec running and see that it fails. Bam. Category property then of undefined. Beautiful. So read text is supposed to return a promise of type string because that's what the browser API says. But we stubbed this thing and we replaced it with our own version here. And so now read text is this the result of this SPY, and it's actually not doing anything yet, and the SPY is not set up to return anything. So I thought we were next going to write a test for test call, but it turns out we need to still work on code here in this class before we can even make the rest of this test work. Cool, that's great. Um, um, One of the things that I think is cool about live coding, this is not a tutorial, this is not a curriculum, you're just watching me code. I do this with the guys on my team at work um, once or twice a week just to get them sort of as a mentoring thing, more of an apprenticeship type thing. And you pick up things that I would never think to write. I can run across these kind of situations I would never think to write in a tutorial. So what I've done here, I found out that I'm not ready to write this test yet. I'm going to set that aside. I'm going to come back, and even though this test might exercise some code here in this file, I still want to test anything that's written in this file. I want to have tested in this file. That's what it really boils down to. And so I'm going to set this test call aside for a minute and come back here. And I need to do some more work from here first to get this working. I need to be fancier in here so that this spied method actually returns a promise that you can do a .then against. So for that, we're going to describe the constructor, really. That's where the code's going to go. And so I guess the user doesn't really care if it's done in the constructor or not. Or, I could put the code here or there. It's not really. No, the user does care. Because the user then, all you have to do, right. So it allows the controlled method to be called immediately. So from a user perspective, as soon as I create one of these objects, I can start using the thing that I'm stubbed out, that I'm controlling. So since this activated the problem for us, let's start from this and sort of tweak it to meet our needs. Read text. We don't really care about this SPY. That was the line that failed, though. We don't care about this SPY, so let's just call then. It just should be able to call then. I could test that it is promise-like, that it has a function called then. I don't know. Feels a little more natural to just call then and make sure that. So let's just do expect this not to throw error, right? I mean, that's going to be enough. That's going to be enough for a failing test for us. We don't need this variable. Oh no. My linting and my TypeScript are not letting me boil this test down to the minimum necessary. A philosophy when writing tests is to make it the minimum necessary to clearly demonstrate the description of the test. If you want to test more things, either make the description broader to capture everything you're testing or write multiple tests. I don't know how to describe the balance to strike there, when to add more tests and make the description broader versus split it up. I don't have any guidance available, that I'm ready to articulate. I think I generally tend to like them pretty small. Maybe with time, I'll think about that as I write tests and have more to say next time this comes up. Um, Allows the controlled method to be called immediately. This is the minimum, so actually TSLint, I know what I'm doing. Just disable that, uh, and that should do it. So now we should have a failing test here. If we go back to test async method controller, bam, it threw a type error. Um, so let's satisfy this test first of all. So when we spy on this guy, dot resolves with and resolve to, that should be enough just to satisfy this particular test, and we will work more on this later. Bam. So now we told the spy, you need to return a promise, and the value is going to be undefined. So now we're allowing it to be called. The problem is it shouldn't resolve right away. It should wait and not resolve until we call flush, and then it should resolve with that value. So we need a failing test for that. And where should that test go? The tricky thing is there's going to be code for it in two places. Here we're going to set up a deferred, which I'll talk about in a minute. I have that up ready to go and show you. And then here we're going to pass in that, we're going to pass in that deferred to here and then resolve it from here. This is a tricky thing. I often don't use TDD, test-driven development, because I want to write the test next to the line, in the same file as I write the code that it's exercising. And sometimes I don't know until I know the solution, essentially have written the code so far in my head, which I might as well write it on the page, before I even know where to write my test. So yep, because it's sort of split in multiple places, I'll get this down on the page so you can see it yourself as well, and then we'll continue thinking about where to put the test. So we're going to want to pass in a private deferred, which is a deferred of type, of type T. Yeah, we got, I'm going to put more thought and work into the typing of this later. I think I'll make that a video of its own. Normally I would probably go off on that tangent now, but I don't know, it seems useful to keep these videos more focused. I can put a title on there that more closely matches what you might want to learn. Okay, so I can just put an any here for now. And then flush is going to call deferred dot resolve. Resolve with the value. This could be any value, and we're just making it any for now. Okay. So how do, I haven't written all the code yet in my head. We don't have a deferred to pass in here. We need to resolve to, Each time you call this spy, here we go. Each time you call the spy, we're going to need to make a new deferred that you can then resolve later. Okay, so let me explain what deferred is before we before I keep just thinking on my own and leaving you out of it. So deferred is something that I have in one of the other libraries, JS Core. It's not something I made up. It's a common pattern. I think it might have been in Angular 1 even, but when Angular included its own promise library because it wasn't in the JavaScript spec yet. I could be wrong there, but anyway, I've seen this before in other places, in other JavaScript libraries. It's an object that has a promise and functions that you can call later to resolve, to cause them to resolve or reject. So if you look at this example up here, you create a deferred for like a string, and then later you can call resolve, and that is when deferred.promise will do its thing. So when you construct this thing, okay, so when you call it, we can't pass an evaluate resolves to right away. So we are going to have to make our own a fake. So we're going to call a fake. I think we don't care what the value is. We're going to a new deferred here, import that from my other library, and we're going to return deferred.promise. And then down here, we somehow have to get a hold of that deferred. No. Yeah, to pass into our test call here, so that when you call flush, it will resolve it. And how are we going to get it in there? Let me just clean one thing up here. Oops, $. That's what I'm used to typing for observables and jQuery objects. Okay. Type promise is not assignable to parameter of type ON. Boo. A spy of ON. It should know that it's an async function. What does it think ON is? Again, I need to make this a lot nicer, but I want to treat that as some separate separate thing for the sake of these videos. Okay. Put another note here. Lots of notes. Make this typing better instead of any. So then when I do the video in the future, or at least the work to find these types, I'm going to go look for all these to-dos and make sure I cover all of them. Where do I keep this thing so that I can get a hold of it here? Or alternatively, what do I keep so that I can return the test call here? Yes, let's stop using this spy.calls and start making our test calls in here, storing them up here in our own array of test calls. That's going to be great. That's going to be really useful later when we want to remove them selectively from that array after you expect one. Okay, so instead of, I think probably instead of, we're going to want, I don't know, test calls, which is a test call array. And then in here, we have the deferred. We're going to do this dot test calls. We're going to push a new test call, basically this guy. Oh, which is the call, has to have the call object. And we don't have that call object yet. I don't think. Let's just make sure. Call fake receives a function. Yeah, we don't get past that call object. And so when we call match, maybe we can add in the call object. We could see if we can get it from the SPY right away. So we know we want to pass it this deferred. We don't yet know how to get both the deferred and the call object on there. I don't let's just get this compiling, and then I'll set a breakpoint here and see if we can get a hold of that call object. And if so, we'll go look at the docs to see if we're, guaranteed to be able to get a hold of that call object, which is a different question, one that you should verify. And then, sorry, that distracted me. Goes with that line. And then if it doesn't work, if we can't get it from here, we will hackily get it in from here instead. Okay, so here we're not returning that. Let me comment this out for now. We might want something similar by the time we're done, but for now we want to return this dot test calls dot filter by, and we have to pass it. Oh no, that's going to be okay. So we're going to call this is a test call. We're going to filter by match of test call dot call info. Right, so this is a call info object. Yeah, that should be it. And this is going to fail. This doesn't work anymore because this is undefined, and some tests are going to fail. But that's okay. All I want to do right now is get this running so that I can set a breakpoint and see what we have available. If in here the question is, does the SPY object have this call object ready for us yet to use? Yeah. So we want a breakpoint in the async method controller to refresh it to get the new code in Chrome. And I'll set a breakpoint around line 19. Oh, not the spec, the actual async method controller. Around here. And let's see what we have. This dot SPY, is that a thing? Not a thing. Okay. JavaScript, I think what we're running into here is, no, what are we running into here? Is this down leveled to a, okay. So if I hover over this dot SPY, it shows me something. But when I run it down here in the console, we get an error. This happens when it compiles into something with a different name. If you are looking at minified code. And so in here, it's using the source map, and it's able to figure out what name it should actually use in the JavaScript itself, because this is the TypeScript, and what we need is the JavaScript name. And if we're in here, it uses source maps to understand that mapping, but down here in the console, it does not. You have to know the JavaScript name itself. So let's see if that's what's going on. Let's turn off source maps. And what do we have to work with in here? We have underscore SPY. It's a variable. Okay, yep, it was down leveled to some other version of JavaScript where it's just captured in this, what do you call this again? The scope, the closure. Because this class is defined inside this function, they're able to make these variables like this, which then are truly private, that someone else cannot ever access by using this dot anything, because it's actually not on this in this down leveled. version. I've never seen that before. That's cool. Now I know how that works. So what we want to do is look at what spy, see what's available on there. Spy.calls is undefined. What is spy? Spy is a weak map? Oh my, the down leveling is even fancier than that. Spy dot get this. Wow. Dot calls. Okay, so what I figured out there, spy is actually not the variable that you put spy on because, yeah, right, it can't be because this is a map of the spy private variable for um, every instance of this class that you've created. And so it's a weak map. We saw that in the typing here. It's a weak map, which means that once the key is garbage collected, then that can also be eligible for garbage collection from the from the from the weak map itself. It's going to be whatever we actually set in there. So like here we're setting it to the result of something. We should see that. Where is it setting it? Oh, and okay, it's even more complicated. This method behind the scenes is going to call underscore spy.set and give it the results of this code that we actually wrote. So anyway, all that to say, if we want to access these things from the JavaScript console, this is how we have to do it. So how many calls do we have? Dot count. Dot count. Ooh, we do have one. That's fantastic. This is the first time it's called. It's already available there. We could get a hold of that. So let's see, we do calls dot, I think it's called last. No, is it here then? Most recent. So here's our call on the clipboard, which we could pass to our test call object. Now the question is this a guarantee from Jasmine that this call will be available to us by the time we're in this call fake method, this call fake callback? Or are we just, being super hacky and tricky and seeing that happens to be available in this version of Jasmine, but we wouldn't want to rely on that. If you're in the habit of just doing that and moving on, then every time you upgrade a library, you're in danger of causing a bunch of problems and making all of your upgrades a lot harder, even if you cover it well with test coverage, which even then is maybe not recommended. Let's see what we can uncover. Let's go to Jasmine first of all and see what their call fake. It's going to be in the spy. See what they say about it. Yeah, not much. This is not it. Calls fake or call fake? Call fake. Spy strategy. Call fake. Tell the spy to call a fake implementation when invoked. And we have basically no information there. So what would be left is to go look at the Jasmine source and see if they have a test for that on their end. We'll see if we can find that quickly or not. Calls fake. No, call fake. And let's see if we can find a test file. HTML. We don't need HTML. Let's look at JavaScript files, please. Upgrading. Upgrading, we don't care about upgrading. JS, introduction JS. I don't know what that is. I think that's maybe their... here's the implementation of it. That could be useful. A test library must have tests, right? No. Well, it must, but I don't know what format they use. So call fake. Don't see any tests here. Where are your tests, Jasmine? Lib? Maybe we have a source. This was in a function called just jasmine.js. Reporter. Ajax. Introduction. What is this? Introduction. Describe. Oh, these are tests. Okay. Let's look at call fake in here. All right. This is what we wanted. Before each, we do a bunch of stuff. It tracks that the spy was called. Should not affect other functions. It should not affect other functions. So, when you spy on foo.getBar, it does not affect bar. I think I understand. I can't see it. But anyway, when called returns the requested value. Nothing in here about whether it's available in that calls array. So the one other place we could check is in the calls array to see if that has a spec for it. Oh, let's see. That could be maybe here. Calls. Let's see. If so, it's also going to need a call fake in that test. It's going to need to look at both calls and call fake. And this is the only three places we have call fake. So let's not rely on it. That's disappointing. That's too bad. It means we have to be a little hackier. It means we need to probably only pass in the deferred, since that's what we have for now, and then we'll set the call object, the call info object, later. So this is going to be here, not from the constructor. And by the time the user gets a hold of it, it's going to exist. I'm not in the habit of putting an exclamation point on things unless I know. My rule is once I know everything is initialized, that's when I decide between an exclamation point and a question mark. So this says that this will not be undefined. This actually will exist. If you initialize it here or initialize it in the constructor, you don't have to put the exclamation point there. TypeScript knows. But if you don't want it to have or undefined, and you do want it, and you know that you're going to have to initialize it later, not in a way that TypeScript understands, you have to put that exclamation point there. Okay. So now here, oops, no, I was keeping that. We could, I don't think there's any way to be able to set that at the time that the user actually makes the call. So instead, we're going to have to set it at the time that we expose this test call object to the user, which is in this match function. And so And the only way we can do that is, oh man, is by matching array indices. How can we match a test call object in this array to a call from this SPY? We will know that by the time match is called, in the future, we're going to be able to remove things from this array. When you call expect, that's going to remove it from here. Right now we're calling match, which does not. So the array indices between this and spy.calls will not match up. But we will know that nothing could have been removed from the array. Let me write some code and then explain why it works. So let's make a separate function for this. Update set call ensure call info is set. All right, so we're going to make a new method for that. I can't remember, does JavaScript have private functions or only private variables? Yeah, a method cannot be named with a private identifier. We could get around that. I haven't played around with these much yet. We could get around that like this. Or we could stick with just private. I feel like that's a little too tricky for me. This is kind of new. Maybe in the future they'll have methods available. I'm going to stick with this for now. We're sort of in an in-between world where, you know, this private JavaScript native supported private stuff is quite new. Okay, so what I want to do here is loop through my test calls in reverse to find ones that have not yet had their had that call info object set where it's still undefined. And because we're going from reverse, we'll know that it's going to match the calls in this array starting from the end. So how far it is from the end is actually going to match. We may have removed some from the beginning, but not until we had already matched them, in which case they already had the call info object. So let's do that with, for let I equal 0, I is less than this dot test calls dot length test calls. Now, do I have some nice helper to grab an index, a negative index to go from the end of the array? Do I actually need to write like dot length minus I here? Dot length minus I minus 1 or whatever? That's a great question, and it's going to be answered by, does Lodash have such a function? Hopefully. So let's see. Yeah, we don't care about you anymore. Lodash. Yeah, let's look at array functions. And in fact, let's just use, nth. Guess the element at n. If n is negative, the nth element from the end is returned. So that's what I want. And I don't think I have that in microdash yet. One moment while I clear my throat. Oh, sorry about that. Okay, so one of my libraries is microdash here, and that is a kind of a clone of Lodash. Here, I'll pull up the description since I've actually thought through how to describe this before. um, Pull up my suite of libraries. And let's look at microdash. It's a much smaller Lodash, a subset of functionality with drastically reduced bundle size. So Lodash is like this standard awesome utility function library that just has all kinds of cool things. Like, it has this function already written that I wanted. Trouble is, when you import a function from Lodash, many of them somehow give you like 14K worth of minified code in your bundle. Um, in fact, yeah, let me just continue pursuing this. So let's just look at, we see we don't have at here. This is microdash. I've done my own version of many of the functions in Lodash, however many that is, with the same API, but pared down. It only works with plain JavaScript objects and arrays. Um, the string manipulation functions. Don't worry about like characters with accents and stuff like that. Um, so it's dumbed down to only work with the common use cases, but it's so much. I mean, I don't know. Let's just look at the first one. Um, so if you grab bind key from Lodash, you're going to get 9K, almost 9K worth of code in your resulting bundle. 69 bytes if you get it from microdash. So I don't know what exactly, how fancy exactly they're trying to be there, but I prefer to write my own and reusable, same library, same API, without having to worry about making it my app have a worse experience for users on like a mid-range mobile device that can't handle large bundles as well, or a slow network download or that sort of thing. Okay, so the function I want to use is in Lodash. It is not yet in microdash. So my process there, I'm going to make if I was in a library, or sorry, an app, not one of these libraries, I'd make a to replace, and I sort of sketch out code that I am going to want in one of my libraries later in the place I'm trying to use it. I get a really simple version working just for the purposes of being able to continue what I'm doing there. And then later, once two of my apps want to actually use one of these things, I'll extract it out and actually make it in the library, write the full test suite, whole 9 yards. So let's just do that here. We'll call this at. Oh, actually, in my pattern here is to put it in a directory called microdash. So sometime in the future, I want to basically move this file into microdash and then replace any place that's using it. That's the to replace. Anything in here that's using it, I replace with the one that is now in microdash, or that will then be in microdash. Anyway, export a function at, which takes an array. Let's see, this is array of things, and index, which is a number, and then if index is less than 0, index is going to instead be array.length minus 1 minus index, and we'll return array index. Right, I have to say this returns a t to satisfy my linter, and hopefully that's going to work for us. We won't go to the trouble of writing tests for that, as I said. But here, let's test calls. So we're going to use our new function at. And give it -I. Ooh, but does -1 give us the last element? Or does 0 give us the last? -1 gives the last element. So it has to be -I minus 1 instead of having the -1 there. Okay. I assume, unless -0, let's see what Lodash does. We need to make sure we obey Lodash's rules here. So if we do at 1, 2, 3, -1, is this going to give us 3 or 2? It's going to give us undefined. What? Am I going crazy here? Oh, not at. Oh, that's why I'm going crazy. What was it called? Nth. Nth. Gives us 3. And if I give it -0, it gives us 1. Okay. Nth. So the 0th time through the loop, I want to give this, you know what, let's start at 1, go less than or equal to, and give it -I. Okay. So there's our test call. If test call dot call info already exists, our work here is done. Otherwise, test call dot call info equals the nth spy dot calls dot calls dot all, was it? Yeah. Here we go. We're going to type read only blah 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 is not assignable to that because of the read only. So we need to make this. Do I put it here? Read only array of t. There we go. Dot. Oh no, not dot anything. That's it. That is the call info. Hopefully you can see how that works. We're going to have to do some real test coverage on this guy. Unfortunately, we're not going to be able to really test it until we have that expect function, which will actually remove something from test calls. The reason I wrote this, so going from the end to when we have expect 1, test that this works with mismatched arrays, whatever. This returns void, satisfy my linter. There we go. Whew, that was a lot of work. We can't remove this. We are actually using it. Now, did we have a failing test that this should have fixed? No, we had written, well, we do have a failing test. Maybe that'll be working now. Nope, we made everything broken. Cool. Failing test, let's fix it. Cannot read property call info of undefined. Oh, can't click on. What is going on? Why can't I click on those? That usually works. Line 36, I'm not going to worry about it right now. Let's get our, let's get our source maps back. and see where we are. If you set a breakpoint in the JavaScript, when you have source maps turned on, it'll somehow magically take you to the TypeScript version. It's just a little trick I learned. So in the controller on line 36, okay, that's here on line 36, not read call info of undefined. My nth function is not working. Okay, so if we want to get, let's see, the array has 3 things in it. We're trying to get index 4. What? I is 1. So array.length minus index, yeah, is just the wrong way to get the index from the end. We want the we want the index what do I want this to be? I'm having trouble doing this all in my head. So if the length is 3 and I is -1, we want the value to be 1. Nope, 2. And if it's -2, we want it to be 1. And so, oh, it's negative. It's array.length plus index. Okay, that, I don't know why that was so hard for me. Let's leave that breakpoint and make sure that that's giving us what we want. Ay. Stop it. Refresh. Okay, so if our array has 3 elements and we are trying to get 2, then index, oh, we need to stop it before we modify it. If our array has a length 1, we're trying to get -1, that should give us 0. Index is 0. Okay, I think we're looking good there. So we have exactly 1 failure, good progress, finds matching calls. And I can't click on that. What happened? Why can't I do that? I need to investigate. Nope, I was just searching to see if there was some trick that I've used in the past I remember that would have broken that. I won't investigate during the video, I guess. So line 25 of the test here says we can't read property 0 of undefined call.args is undefined? So the call, okay, we must just have the wrong thing in there. Let's so I want to set a breakpoint right here and see what this call object is. I could go back and set it instead in the place I know it's being called from, but for the sake of giving you a new tip, I will do it a different way. I'm not able to choose where on this line I want this breakpoint to go because I'm in the TypeScript and it's not that smart. If this was in the raw JavaScript, we could do that. So that's option 1. I guess I can show that to you. Let's turn the source maps back off and look. How do we find, when we can't click this guy, how do we find our line? Turn it back on. I'm going to set the breakpoint here. That's near where I wanted it. Now I'm going to turn the source maps off and find it. There we go. And now I can come in here and say that's where I want my breakpoint, not there. Rerun this guy, and call is a deferred. Aha! Now I understand the problem. In our controller, we had this filter. Aha, we're passing the test call, our deferred. Nope, I am not understanding the problem yet. Why is that? Why is that a deferred object? Call info is a deferred. I must have set it wrong down here. Call info comes from there. Test.callinfo. That's surprising. Okay, so testcall.callinfo is a deferred, and that's wrong. So let's set a breakpoint and see what the heck is going on there. Let's go here. Hmm? Why are we not hitting this breakpoint? We should be getting to here. Yup. Maybe these test calls are getting their object. Why do you say that's an object? Are getting their value set. Let's see, that was called underscore test calls dot get this 0. Let's look at one of them. Call info is the deferred, and deferred is undefined. What? I think something might have messed up. I think we might have gotten a weird problem. This is a real issue. If this is the case, if I restart Karma and it fixes it, Angular, or no, I guess Karma has got some serious problem to fix. You know, I wasted however much of all of our time doing that, except if you know, when you're watching this video it still has this problem, maybe you learned something from this. So it wasted at least my time. Let me just see if it's a problem before I continue that rant. 987.6. Yeah, that's left over from before. Okay. Never mind that. Oh, look, the problem went away. Okay. Yeah. Again, I can't remember if I said it already in this video, but when you have an error in a file and you're editing multiple files, any changes you make to another file while the one with the error still has the error doesn't get caught, doesn't get picked up by Karma. And then once you've solved the errors, it says it's ready to go, and in reality it's just like this corrupted compilation. It's very disappointing. That's only in the more recent versions. I can't remember when exactly it started, but anyway, major disappointment here. But in terms of our progress, it's looking okay. Um, excuse me for that. We are way down a rabbit hole here, and it's time to backtrack and see what we're actually trying to do right now. Causes the call to resolve with the given value. Whoa! Did we fix that? Oh, we don't know. We don't know. It's a test call. Okay, so what do? We got allowing the controlled method to be called immediately, and in such a way that we didn't break any of the other tests. And so now let's see if this one, what is still needed to get this one to pass. So for that we want to run, you know what, let's just run them all. They're going to be super fast. Another thing that's broken in only the most recent version of, I think probably this Jasmine reporter that writes this HTML, is if I click here, it used to run just that test, but now the URL that this link result points to is wrong, and it's going to run the whole test suite. Not only that, it's going to run the version that reruns every time you change your code. So if I want to run just this test, I'll show you. I'm just going to copy the description and put it here. Okay. So we expected the SPY to have been called. It was not. Let's see where we left off here. We have a deferred. We make it resolve. I'm kind of surprised that's not working yet. I feel like that should have done it. So there's some problem somewhere to dig into and find. This creates the stub. This registers a listener on what should be deferred.promise. The match should return the test call with with the test call with this same deferred object, so that when we call flush on it, this should cause it to resolve. It caused it to resolve, but it did not run the function yet, because in JavaScript, promise resolutions happen on the microtask queue. If you're not familiar, this is good information to know. So when you do things in the browser, click when a network request resolves, when you scroll, any DOM event, those are queued up on the macro task queue, and they hop in order. Only one runs at a time. JavaScript is single-threaded. It can only do one thing at a time. So if you click and at the same time a network request resolves, the browser is going to have to choose to do one first and then the other, and it chooses that by this queue. And as you're processing the network request, if you click 3 times and scroll and then something else happens, they're all going to be added to that queue. Now within the processing of that one event, so like the click event, promises go on the micro task queue. So the macro task is the big event. Promises happen within that. If a promise resolves, it goes on the micro task queue, and it will happen within that one bigger macro task, that one click event. So you can't have a promise resolution that gets interleaved with things happening from a different, like from the network request resolution or something like that. So uh, this should be queued up now on the microtask queue because we resolved it, but it's not actually going to run this callback yet. Um, so for that, we can go a couple different routes. We could use Angular's fake async zone to call flush microtasks, which might be a nice way to go. It's very clear. It's written out exactly, more semantically what we're doing there. Let me show you the other option here, and then we'll decide between them. Um, so we'll do, instead of using a spy, we call flush, and then it's still part of exercising the code. We await the promise. Then we're going to expect value to be the clipboard text. Whoops. Oh. So the other option is using Jasmine's asynchronous built-in features. So if the callback you pass to it, the test itself, is asynchronous or returns a promise, whether or not it's via this async language level feature. If it returns a promise, then Jasmine is going to do the whole microtask thing itself. It's going to wait for that to resolve. It's going to register itself as a listener, put itself as like a dot then, and let the browser run its micro and macro tasks as necessary before it then says that this test is done. And so anyway, that was a long way of telling you the reason why you're allowed to do async Jasmine tests, and we can put this await here. And so then with this, we're going to give control back to the browser. We're going to yield from at least our micro task that we're doing right now, and let the browser process our promise that should have resolved here, and then come back and expect that value. Let's see. Let's see if that was the only problem. Hey, all right. I kind of like that. Just for fun, we could try the other option. Um, we could run this in Angular's fake async, and instead of putting an await there, we could go back to our whole spy thing. I could use my local history to find this, but I feel like it's going to be just about as easy to retype it because I saved that. I foresaw this. Yeah. So here we want to do flush microtasks from Angular. We don't keep the promise anymore. Read text. Oh, right. I should have gone to the local history dot, then spy. Okay. And let's see if both of those work. Yeah. So this gives you a little more insight into what the fake async zone really does for tests. It gives you control over those tasks. The flush micro tasks will do what I already described in .tick, which is another function from Angular's testing library. Tick. We'll run macro tasks. And of course, you probably already know about passing it amount of time to elapse. So it will run, these will run micro and macro tasks that are ready to resolve. They're not like something that are scheduled to happen in the future with like a set timeout, um, with 1 second later. So this would not do my thing, but this would do my thing. It runs the macro tasks that are scheduled to be resolved or whatever, executed within this amount of time. Okay. Anywho, which do we like better? I don't know. I feel pretty even about both of them personally. I mean, they're equally succinct. Um, this one allows us to use await, async await, which is a more natural. Any promise-based stuff, I always use async await when I'm doing production code. I was really only using dot then here because I was trying to think ahead to how we would end up getting a value into it by the time the test finished. Turns out there's two different ways to do it. This one's nice because it shows you that it's microtasks, and if you're familiar with that language, I find this to be a more expressive way to reveal to the reader of this test what's going on. This one is maybe a little less clear. And so maybe for that reason, I'm going to stick with using Zone.js. Or I guess Angular's testing wrappers around one of their zones, the fake async zone. Okay, great. Gosh, one test written and solved. I feel like it's been a video's worth of content and more already. So I hope that was interesting. I struggled a bit, and I think that's kind of part of the point of this live coding. Because if you wanted to see something polished in tutorial and curriculum, you'd go look for one of those videos, right? The reason you might want to watch my videos is to see how I work through problems that I, live. Get a feel for my troubleshooting process, that sort of thing. So hopefully you learned something like that if you stuck through with me this far. Let me know if you're enjoying things in the comments, if there's some suggestion to improve things, and I'll see you as we write some more code for this thing in part 3 of this series of unknown length.